Semiconductors have been a game changer in transforming electronics and making devices compact and powerful over the years. Almost everything we touch and interact with today contains microchips. A chip is an electrical device that contains transistors, resistors, and capacitors. They are built up layer by layer on a thin slice of semiconductor material known as a wafer. The wafer is a substrate of single crystal silicon used to make electronics and other micro devices. Around 12 billion square inches of wafer area is annually produced, which relates to 1,100 soccer fields. That is the level of our playing field. Did you know, in the beginning, transistors were made from wires and germanium, a semiconductor material? Wires are still being used, but what is phenomenal is that they have now transitioned from being visible to nanometer scale over the last 4 decades. Today, transistors are typically built on processes as small as 7 nanometers or 10 billionth of a meter. This need for miniaturization is driving new chip architectures like vertical 3D NAND memory technologies. 96-layer structures are currently being launched. If you compare this to a building, it's like stacking the tallest building in the world, the Burj Khalifa, 4 times. Until 2022, NAND with up to 256 layers is expected, which is equal to stacking almost 11 Burj Khalifas. This is what can be achieved in semiconductor manufacturing. What role do we play in making this a reality? Our specialty chemicals and gases enable our customers to construct the desired structures in nanoscale. With the acquisition of Versum Materials and Intermolecular, we are the only company in the semiconductor ecosystem to participate in all 7 critical unit operations. The making of a semiconductor is a complex process and consists of various steps. Silicon wafer is the base material used in chip making. Using photolithography, fine structures are transferred onto the wafer. This process is known as patterning. In the deposition phase, materials are applied onto the wafer. Planarization is a process step during which the surface is flattened and unwanted layers are removed. Etching is removing those parts from the wafer which are not protected, for example, by the photoresist from the patterning step. Cleaning is a process in which solutions are used to remove unwanted residues from the wafer. Doping changes the electric behavior of the silicon to create a transistor. Once wafer processing is complete, the wafer is cut into pieces and then packaged. The package supports the electrical contacts that connect the microchip to the circuit board. This is how semiconductors are produced. Today, almost every chip uses one of our products. But that's not all. You can now also hire our independent materials innovation expertise through the Intermolecular R&D services team. In addition, our delivery systems and services business enables the safe and cost-efficient use of specialty gases and chemicals that are delivered directly to our customers' manufacturing tools. We are materials creators, innovators, and inventors, helping our customers create next-generation digital devices and experiences for a smarter, safer, more connected world. We are the company behind the companies advancing digital living.